Hello and welcome back to the Go Rust channel. We are going to have an exciting time, I hope. Excuse me, sorry about that. I had to sneeze all of a sudden. That's embarrassing. So yeah, let's get going. So in last week's episode, we kind of finished up what we were doing and made the app successful. Like it actually would pull data from YouTube based on a search. It would get the details and it would pop out the data that I wanted either to the command line or it would pop it out to a CSV file, which is what I wanted. So with that, I would say that we were successful in that project. And so I'm calling that one done. I want to revisit that in say 6 months and do a refactoring and kind of clean up some code and kind of basically be like, here's where I started and then here's where I am now. But for now, we're ready to move on. So it's kind of like, what's the next project to learn? Since I'm wanting to move the systems programming route, and specifically I've always been interested in networking and things of that nature from a programming perspective, I want to write an application that I've kind of always wanted, and that is to be able to get an interface that shows me all of the things that are on my network, what their IP address is, and preferably what it is, and then what are the things on that server, that host. So as part of that, I have actually been doing a lot of reading outside of doing this on networking, and there's kind of several approaches that we can take, and I'm not exactly sure fully the direction that I want to go. But one thing that I did think about is I need to figure out how to save everything to a database. And I need to deal with a database. So in today's episode, we're going to take a dive into SQLite. I haven't touched it in a few years, so I kind of get back into that. And then we're going to see about connecting and using Rust with SQLite to do basically CRUD operations. That is the goal for today. If we finish up with that, we might move on to something else, but hopefully we can get all that time boxed into today. So the first thing that we're gonna do is switch over here, and we're just gonna cargo new SQLite demo. Just create a new one and then open up our source and then cd into SQLite demo. There we go. Awesome. We are ready to get started. So with that in mind, let's go over to our browser. Maybe if I can choose the right one. Awesome. Okay. Let's just start. I mean, let's start as if I've never touched SQLite. What is SQLite? Dismiss. SQLite is a C language library that implements a small and fast, self-contained, highly reliable, fully featured SQL database engine. It is the most used database engine in the world, built into all mobile phones, and holy crap, that's a lot of stuff. Basically, I'm going to summarize this. It's a text file, in a sense. It's a flat file that has SQL data in it, and you can query it. So let's not look at this. How can I get started with SQLite on Ubuntu? If that keeps popping up, I might have to switch to ChatGPT. All right, so oh, that's a good call out right there. I didn't think about the SQLite dev, so let's do that. Oh, I guess I got it installed. All right, SQLite 3 version to make sure it's installed. Sweet, there we go. And then we need to create a new database. To create a new database, use the SQLite 3 command followed by the name. Okay, SQLite 3 demo.db. Nice, nice. And okay, awesome. All right, let's do, I like this. Let's take this, copy, paste that. So we're in the console command line of, so we don't want to do users, we want to do host. hosts. We have an ID. It's going to be integer, primary key, name of the host, text not null, MAC address, and that's probably good for now. Oh, and let's do IP address, text not null. Sweet. We now have a database. And I think it's no. Oh crap. There we go. Okay, SQLite 3. Select all from hosts. Nothing. Okay. Cool. That's fine for now. Oh yeah, dot exit. All right. We're going to come back to inserting data. How can I see my SQLite schema? ChatGPT is looking a lot more like you're going to be used. Dot schema. Okay, here's dot schema. There we go. And there we go. So that's some basic usage. We have created our database. We have created a schema by creating a table in there. And that's always been the interesting thing about SQLite to me, is that in order to have your schema figured out, it just spits back at you what you use to create the table. It's like a genius idea. And anyway, I just always thought it was really interesting. So let's do insert into hosts. It's gonna call me on the spot, and I'm not gonna do the interesting. We're gonna do MAC, new name, MAC address, IP address, and then we're gonna do values. It's been so long since I've written raw SQL. Home 123, just because 127.0.0.1, and there we go. Select all from hosts. There we go. Select name, IP address from hosts. There we go. We have we have a result, and we've queried it two different ways using SQL. So we know that it's working. So let's do home server 123. We would probably want to use some sort of unique index on the MAC address, but we're not going to worry about that at the moment. It's more of an implementation detail of the database schema. And all we're really concerned about is kind of getting a little bit back in the feel of using SQLite, and then how do we connect and use Rust with that. So I'm going to take a couple more minutes, do a couple more things with SQLite, and then we'll move on. 192.168.1.234, and then select all from hosts. Awesome. And let's do local cube and do 21312, and then we'll do this one at 200. Select all from hosts. Awesome. Now we want to delete from hosts where ID equals 3. Okay, now let's go ahead and let's add that one back, because I want to see what the ID is. And it's 3 again. Interesting. So it doesn't keep track of what all the existing IDs and auto increments up based on kind of a global IP for that table. Anyway, interesting. Doesn't really matter at the moment. I was just curious. Okay, cool. And then dot exit to exit. Man, let me tell you, that one took me a long time to figure out on how to actually exit properly. A little bit on the ridiculous side. Like, I kept trying all these different things. I'm like, I don't know what it is. Finally, I'm like, I should just Google it. And when I saw it, I was like, it's kind of stupid. And I should have Googled it sooner. All right, so now we are where we are. We have our basic database, we have a table, we have some values in that table. So let's go back over and try to figure out how do we do this with Rust. So let's just clear this up and let's do, I am learning Rust and I would like to query a SQLite database that I have. How can I get started with SQLite and Rust? Man, that nag screen is not fun. Cool. Okay, so SQLite. So cargo add SQLite. Oh. Cool. 40 deactivated features. That'll be something interesting to research later. All right. So now we want to open a connection. So let's just copy this. Paste. All right. And then interesting. Let's copy this, and then I want to break down what it's actually doing. Select name and IP address from hosts, and then I want to do this from demo.db, statement.queryMap, no params, row.get, that's put in row select column 1, column 2, That should be good. I mean, that's going to be a pretty basic thing. Let's do cargo run. No params not found in this scope. Huh. All right, no params was not found in the scope. Okay, we're going to ChatGPT. Okay, that's kind of what I figured was going to need to happen, but I just wanted to check. No params. All right. Now let's run this. No param, SQLite, result, no param, result, no params, right? Yeah. Line report along with other necessary components from SQLite crate. With this import, you should be able to use no params in your code without encountering the not found in the scope error. Remember, no params is a constant provided by SQLite crates to indicate that a SQL query does not require any parameters. It's used in scenarios where you're executing a SQL statement that does not need any parameters, such as creating a table or inserting hard-coded values into the database, for example. Okay, that makes sense. TX, okay, that makes sense. And that's exactly what we're doing. I don't understand the query map thing. Statement prepare, we're doing a select from hosts. I'm not sure. Okay, so we're getting what is the prepare? I am learning Rust and SQLite together with SQLite. Here is my code. I am getting an error. First, we need to solve the error that we have. Then we can try to figure out what the code is doing. Like, I want to resolve that first. The error is not found in the crate. This is likely because no params has been removed or never existed under the name in the version of SQLite you have. Okay. Let's just try that. Required by the bound. Okay. Can you rewrite this to be better? Let's just see what it gives me. Like, I hit hello. Just went into the ether. Like, what just happened? What? When your tooling goes AWOL here? Okay. SQLite. Yeah, something. Okay. Features, I don't know what bundled feature is. This is the example. Statement prepare, statement query map. Okay. So yeah, so this is kind of the direction that I wanted to go. Let's copy this out because it's okay, person. Interesting. Okay, let's do this. Copy, paste that out. Let us delete this. I want to do a struct host IP name date. What? Oh, okay. Host, so ID, name, MAC address is a string, IP address is a string. Okay. So then we're gonna kind of select all from hosts. Whoa. Okay. So that's gonna call. That's gonna, verify. I mean, that's gonna throw an error. We're gonna bubble an error up if something is wrong. Then we're gonna do host ID road I get 0, name road I get 1, MAC address, and then we want to do IP address road I get 3, and then we'll save. That's gonna return back an okay response there. It's gonna throw an error if it doesn't work. All right, cargo run. Everything is awesome. Fields ID, name, action are never read. Oh, yeah. Okay. So for, oh, no. Well, let's host iter. For host iter, and host. Okay, yeah, so that should output some stuff. Yep. So we want to use that construct, the colon question mark. So we do need to derive debug from that. There we go. There are our results. So like we've actually already done some pretty cool stuff. We have connected to the database. We have successfully selected stuff from the database. We have put it into a struct of what we expect. And then we have semi-output the data in here. This is interesting though. The query map, the prepare to get the statement and then doing a query map, then I guess doing a closure inside of that. I'm a little like, so what I'm assuming is happening. So let's walk through this and let's ask Jippity. The query map will return an iterator of some sort. It will do the query. And for each row, it is going to return a result object, or an optional, probably a result. And then it's going to create a new instance of host with the ID, and it's going to get it from the position of the query. So in this case, all. So it's going to be our default, and return it back. So let us save that. Is ChatGPT working? Are you working now or are you down? Maybe, of course, like you pay for a product and it doesn't work when you're in the middle of a live stream and you want it to work. This is my code. Can you explain it? Specifically, I want to know why we prepare a statement and then we do query map. What does the prepare do versus the query map? Dismiss. ChatGPT's back. So I have the following Rust code. Can you explain it specifically? I am after why the prepare statement and the query map and what they do. See, let's ChatGPT versus ChatGPT. All right, your code snippet demonstrates the use of SQLite, a Rust library for interacting with SQLite, blah, 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 blah. Understand the prepare method is used to compile an SQL statement into a form that can be executed efficiently by the database engine. This method does not execute the statement, it just prepares it for execution. Here's what happens in your code. The connection con is an instance of the connection. A SQLite database is created. The prepare method is called on the connection object with a SQL query string as its argument. SQL query blah, which is a simple query to select all the records. So basically, that was a useless explanation. Let's see what this for. Oh, yeah, this is a little annoying, but whatever. The prepare statement method is called on a connection object, in this case the con, which represents an open connection to a SQLite database. The prepare and SQL query, which selects all columns from the table host. The purpose of preparing a statement is to compile the SQL query into a format the SQLite database engine can execute. The compilation step checks the syntax of the SQL query and prepares the query execution plan. That part's interesting. Once prepared, the statement can be executed once more one or more times, preparing statements is beneficial for the performance, especially for queries executed multiple times, and helps prevent SQL injection attacks by separating the query structure from the data. Boom! That makes sense. Let's go to their version 2. Prevention, okay, prepared statement, okay, compilation of SQL is sent to the SQLite engine to be compiled into a bytecode. I'm going to go with this one. It's more detailed. Okay. It's sent to SQLite engine to be compiled into bytecode. The SQLite engine can execute directly. This compilation step is done once, and compiled statement can be reused, which is more efficient than recompiling SQL query each time. Prevention of SQL injection by using prepared statements. The query structure is fixed only the parameters, if any, can be changed. Since the query does not take any parameters, it's not directly relevant here. Okay, so that's cool. That's an interesting defense against SQL injection attacks. Cool. Prepared statements can be more efficient, especially with multiple executions. Cool. So that was a good explanation. I liked it. The query map function is used to execute the prepared statement. Wow, I'm sorry, guys. Like, I am just yawning a lot. The query map function is used to execute the prepared statement and map the rows returned by the query. The execution of the SQL query, the prepared statement, is executed with no parameters, whatever. Mapping rows to structs. For each row returned by the query, the closure pass to query map is called. This closure receives a row, that's what I said, and constructs a host struct instance from it. The row getEnd method is used to retrieve the nth column value from it. It just says it better than me. ID, name, Mac, blah, blah. Iterating over the results. For the results of the map query is an iterator over the result host error. I told you it was going to be a result object. Boom. A result struct. This allows the program to lazily fetch each row and handle it as needed. In this code, it simply prints out the host. Yeah. The use of the statements allows for efficiency. Cool. I like it. We now understand a little bit better what is going on. So with that in mind, can you give me the code to insert a new host record into SQLite? So let's create a new function. Add host. And we want to pass it a connection. Insert into host. That'll probably work. Yep. We're going to pass it in a connection. It's going to execute insert into hosts. Name, MAC address, IP address. Values 1, 2, and 3. So, yep. And I guess this is going to be a referenced. Let's see. New host. See, this is what I was actually going to go for, is passing in this. The params isn't. See, I like this solution better. See, this is AI versus AI. Because I like this better. So let's go with this. And we're going to modify it to fit that just so we can have some practice. And we're going to do host, nope, host at host. Okay, and then we're going to do, and this had SQLite, had a params. I think, no, right? It had params. And then in this case, it did params. We're not going to do that. params host.name. Yep, there we go. There we go. And let's do a function display host. Let's not do that right now. So what we're gonna do is, actually, I wonder. Factor extract into a variable. What? No, I don't know what's going on. That did not do what I was thinking of. All right, so we have that. So let us do new. Nope, let's do let new host equal host.toString. MAC address, I like it. And IP address 192.168.1.32.2string. There we go, because we do have full strings up there. Do that. There we go. And then we want to do add host connection reference to the new host. There we go. And then we want to query for that when we're there. And so let's see what we get. Found host. Okay. Oh, okay. Okay. Yep. And there is our new host. Boom, it's working. And we're calling new functions. We're referencing data. We're doing all kinds of fun stuff. So let's do function delete host. We're going to do, yep, that makes sense. Params. I want to check out what that params statement is. Next, let's delete host. We don't want to delete our home. So let's do 3. And then R2, R2, R3. That's fine. So we want to delete third, which is cube. Then we want to add host, that new host. Let's just do that for organization. And then we want to query. So we're going to do three things in one here. So the delete from host where ID is, and then that parent. I want to go definitely look at that next. Let's run. So there we go. That's something I wanted to validate. So we removed the cube host and we added our host 2 with the new MAC address and new IP address. And then notice the ID is 5. So as long as it just chose the next highest one, even though we deleted an old one. So good to know. Almost inconsequential, but I wanted to check that thing. All right, so and let's do this. Copy. Okay, here, let's look at where the params macro is used to pass values for each placeholder in SQL statement. This example inserts the name, MAC address, and IP address of the new host. The ID field is typically managed by SQLite as an auto blah, so it is not included. Blah. Okay, cool. Executing the insert. The insert host function takes the reference to the database. Okay, I don't actually care about that. Can you go deeper? Can you go deeper into the params macro? Okay, how params work. Okay, so the params macro in SQLite create is a convenient way to pass parameters to SQLite statements in a safe and flexible manner that helps prevent injection at SQL injection attacks by ensuring that values are properly escaped and bound to the statement rather than being directly interpolated into the SQL string. This approach maintains the separation between the code. So it's kind of like it's a validation, it's a user validation step so that you can avoid problems. When you prepare a SQL statement that requires parameters, you use placeholders within the SQL string, okay, in SQLite, and thus in SQLite, these placeholders can be represented in several ways, such as a question mark, a question, blah, 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 blah. The params macro is used to specify the values that should be substituted for these placeholders. When the statement is executed, the params macro supports different forms of usage, allowing you to pass parameters in the way that best fits your specific needs. Positional parameters, if you use that. Okay, named parameters. Okay, so yeah, so if you're doing just the question marks, then it'll do it in order. If you're doing named parameters, I kind of like this value 1, value 2, then you can do that and that. And you could swap those conceivably. Okay, that's cool. Benefits of param safety. To me, that's one of the big keys here. By separating the SQL structure from the data, params helps prevent SQL injection attacks and common security vulnerability. Blah, blah. Convenience, the macro simplifies the syntax for passing parameters and blah. Flexibility, it supports multiple ways to reference parameters by positional and by name, allowing for clearer and more maintainable SQL statements, particularly in complex queries. The params macro expands into an implementation of the toSQL trait for each parameter passed. The toSQL trait is responsible for converting Rust types into the representation. It's a powerful SQLite that enhances safety, readability, and maintainability of the database operations in Rust by abstracting away the complexity of the parameter bindings. And add security. Cool. So I think that's a pretty good introduction. I mean, it's not complicated by any degree. Yeah, we're doing params there. We're doing positional. We're doing one. That's interesting. Interesting. Okay. Yeah, I think we've got a good introduction into SQLite and databases and Rust. We've gone over creating the database, and you could actually do that in here. You could probably a connection.open would create it, and you would create the table and everything. We've abstracted the delete host into a function call where we're passing in the connection and what we want to delete. We're creating a new record based on a host object. And then we're also doing a poll and then kind of displaying the information out. I mean, these are all fairly basic operations, and we would basically expand on those in the future for whatever it is that you need to do. The thing that this does not really cover is database migrations. That is a whole other topic. And considering the complexity and what I want to do with this next application, I don't necessarily know that I'm all that worried about going down the database migration route, because how I want to build the tool is that if the database doesn't exist, it repopulates itself. And so I can just wipe it away and it'll refill itself out. Now I do want some of the more history. I want to add some history information in there so I can track changes to IP addresses over time, just out of curiosity, and other things like that. But at the end of the day, if I wipe it away, I want to be able to query my network and refill in all of the stuff that I want to know. So that is the goal. I could tell I'm tired and I'm talking a lot because I am yawning so much. So on that note, I think I'm good for the moment with SQL. Actually, are there any gotchas with Rust and SQLite that I should be aware of? The SQLite crate is generally straightforward and efficient. However, as with many technology stacks, there are some nuances and gotchas that I agree, that's why I asked, that you might encounter. Here are a few of the key takeaways. Handling of nullable columns. Here we go. When dealing with nullable columns in SQLite, ensure that your Rust code properly handles the possibility of none values. Rust's strong type system and the concept of the option T can help manage this, but it requires explicit handling in your code to prevent runtime errors. Good call out. I like it. Let's experiment with that here in a second. Concurrency in SQLs. Okay, SQLite allows multiple read operations to proceed in parallel, but write operations require exclusive access to the database. This means that if your application involves concurrent writes and a mix of reads, you might encounter locking issues. Oh my gosh. Oh my gosh, trying to deal with that with a past project. Yeah, that was a good time because Python and Django and migrations and downloading large amounts of data and yeah, don't recommend going that route if you don't have to. Go with a different database. I mean, it works. I mean, it really did. It worked. Like, we had to work through the issue, and we just had to put in a mechanism that was strict about how it accessed the database. But it was just frustrating to need a developer on that. I mean, anyway. Each connection in SQLite is tied to a SQLite database file. Creating many connections or not properly closing them can lead to increased memory usage or unexpected behavior. Yep. Large binary data. When dealing with large binary data blobs, be aware that memory implications. Loading a large blobs into memory can lead to high memory usage. Yes, schema migrations focuses SQLite direct interface SQLite with additions. If your application schema changes over time, you'll need to manage. Yeah, exactly what I said. Rest ownership and borrowing rules can sometimes complicate the handling of database connections and query results. I'll bet, especially when trying to return query results from a function or when using results across thread boundaries. Yeah. It's important to understand Rust's ownership, lifetimes, and borrowing rules to manage data flow. Yeah, lifetimes is totally a thing I have not dove into, and it kind of terrifies me. But we'll get there. We will learn that this year, or we'll start. Error handling, yeah, database file management. Be mindful where your SQL database file is stored. Blah, don't care. Don't care for this context. Well, yeah, okay. I mean, those are good. I think the biggest takeaway for us in this case is handling nullable columns with Rust. So let's get SQLite DB. I don't want to have to, unable to open the file is encrypted or is not a database. What? Nope, there is not a SQLite 4.3. That was weird. I have this as my current schema in my SQLite database. I want the SQL to alter the table to add to add uptime. No, that's not a good one. To add first contacted field that is a nullable date field. I know it's straightforward. I just didn't want to write it. Okay. Schema. First contacted date. Yep, there we go. All right. So now we want first contacted, and we want to do, let's do a string right now. And do a select all from hosts. Interesting. I would have thought there would be an extra pipe at the end. Can you give me an alter and update SQL to add a first contacted date for a record with ID 2. See, the reason, like, I don't want to have to go look this up. I just want something so that I can execute it and we can move on about our business. It's one of the reasons I'm asking it to try to do all of this stuff. Like, it kind of doesn't matter in a sense. Oh, okay, that kind of makes sense. The pipe at the, okay, yeah. I was missing what was going on. I was thinking there was a pipe at the beginning and a pipe at the end that was wrapping the whole thing. But in this case, yeah, it is showing it's null. It just, anyway, cool beans, whatever. Okay, what we want to do now is we want this thing to error. So let's do .exit, and then we're gonna do a cargo run. This should blow up in our missing first contacted. There we go. And so now if we add option, and there we go. Whoa. I have, oh crap. It was in caps lock mode and that was totally, oh my gosh, crap. Well, it doesn't matter. Let's destroy. Can't believe, see, first contacted string. Okay, this should still work. First contacted row.get 4. There we go. Let's see how bad this blows up on us. Add host not found. Okay, where? Okay, yeah. That's fine. We want to delete all this because we don't care about that. Like, we care, but we don't care. We can always regenerate it. Okay, error. Okay, cool. This is good to know. So we got an error that bubbled up. Invalid column type first contacted is null. Okay, because it had the data, and then these are all there. But it did go through, and this is, you know, bubbling up errors. Cool, awesome. Now let's do option, and let's see what our result is with that. And there. And we were able to get all of our results. There were no errors. They were all okays. And for that, we have none. Is none? None. If, oh, actually, let's see. Let h equals host dot unwrap, because I'm wanting to experiment. If h dot first contacted is none, host has not been contacted yet, h dot name. Yes, that's what I was curious about. That is an interesting check. Let's run it and see what happens. What? Oh, wait, yeah. I want to do that. Cool. Okay, has not been contacted. Awesome. Okay, now what if I don't think about it, is equals none? What happens? Same thing. Interesting. I just ran some Rust code where I have the option string, and I just did a check with is none, and it worked properly. And I checked with equals none. Where does is none come from? And is it actually equivalent to equals none? The is none method is part of Rust's option. Okay, which is a powerful feature of the Rust language. I love it. ChatGPT is hilarious sometimes. Like, you can be like, hey, how is this thing going? And it's amazing. You are the best in the world. And like, oh my gosh, just like the over-the-topness of ChatGPT is really fun. Anyway, the is none method is an option. Okay, Rust language used to represent an optional value. For option is either sum, containing a value of t, or none, indicating the absence of a value. The is none method is specifically designed to check whether an instance of option is none or not. It returns true if the option is none and false otherwise. This method is a more idiomatic way to perform this check because it directly conveys the intent of checking for the absence of value, making the code more readable and expressive. I agree with that. I'm just curious. Comparing option none is also valid syntax and achieves the same result as is none. However, this approach requires that the t in the option implements the partial equality trait because it essentially compares two option t values. The none value on the right side of the comparison is of type option t, so the left hand side must also be an option t, where t supports an equality comparison. Here's the equivalent check. Interesting. Equivalence and preference. The is none and then effectively check the option, but is none is generally preferred for its clarity and directness. Additionally, is none does not require t and option t to be implementing the partial equal, making it slightly more versatile. In summary, while both methods are equivalent in outcome for checking the absence of value is none, it is considered more idiomatic Rust and is preferable for readability and intent expression. Okay, makes total sense. That is definitely interesting. That kind of is none. You need the implementation of the partial equal or the equality in your object if you want to be able to do the equals against none. So I guess what is none? Because it is a little confusing. So it sounded like none is an option type, but I'm a little like confused. What is none? Because it's a little confusing since Rust is not supposed to have null. The concept of none is in Rust is part of the option enum, represents the absence of a value. Null. Okay, I am probably about to be told off by that flippant thing. In Rust idiomatic way to handle that other languages might use, let's say, represents the absence of a value and is Rust's idiomatic way to handle cases that other languages might use null or nil for. Rust's approach with option t and none is designed to explicitly handle the presence or absence of values in a type-safe manner, avoiding the pitfalls and errors commonly associated with null. references in other programs. The option T enum is defined in the Rust standard library and can take on two variants. Some indicating that there is a value of type T present. None indicates that there is no value present. This design forces Rust programmers to explicitly handle the case of absence, which makes sense, making the code more predictable and safer by eliminating the possibility of a null pointer exceptions, which are common. Okay, none versus null. The difference between none and null in other languages is how they are handled by the type system. Null in languages is important null. Any reference or pointer type can potentially be null, leading to runtime errors. None in Rust, explicitly encodes the possibility of absence in the type system. This means you cannot accidentally use a value that might be none without handling the none case, because the Rust compiler enforces checks for option value. Okay, that makes sense. I like that. That's a good explanation. Just basically like they added. So I use none or nil, in Python as kind of like an absence of a value. Like there's just not anything there. Unless it's a car field in Django, but that's another discussion. So in that case, you have to represent that situation in Rust. So what they're trying to do with the none as an option is to give you the opportunity to handle when you're not going to have anything, because you need to be explicit about it so that we aren't accidentally nulling out a reference point anyway. So it's enforcing that you're doing something correct. I like it. I like it. Here's a simple example demonstrating how option T can be used. Okay, well, yeah, if divisor equals 0, none. We're going to return none. Option I32, otherwise sum, blah. Okay. The result, find divisor intended. We're going to match some value or the none value. We're going to do this. Makes total sense. I get it. I will probably forget it in 2 weeks, but for this moment, I get it. And it makes sense for the context of doing database and having null columns. I am so glad we asked about the gotchas to ChatGPT. Thank you. You just saved some butts. I appreciate it. All right, so I think we've done a really good job going over Rust, and I am sure a lot of you are super nosy about my ChatGPT history, and you've been reading over here while I've been talking, so let's actually go through a little bit of this. So these are stuff that we just did. I don't know what new chat is. That's probably where it aired out. Daytime filtering and Django filter. I was kind of playing around with a couple of different things in Django, and so I was kind of like, hey, what if we did this? So that's all that is. I'm switching back to NeoVim. Like I used NeoVim for a decade, and then there's a couple of features that I really, really wanted. And so I just kind of jumped around to other IDEs and just missed a lot of things about Vim. And so I'm trying to slowly get back into doing NeoVim, get back into Vim with NeoVim, and I'm doing a Lua configuration this time. So I'm learning the Lua language. That's kind of interesting. And so I was dealing with some ISORT. Django URLs configuration. Something was going super duper funny, and I was trying to understand what was going wrong, and basically I forgot to look in a specific urls.py file to see where everything was connecting.
So that was me being dumb.
gRPC versus HTTP. So at work, we've been doing some discussions, and I wanted to get some of the, like, I know the difference between the two, but I wanted to get some specifics about how to intimate the differences more than my bungled understanding of what it is. I just like the way it put it better so that I could have the discussion about when to use either one. I also learned a couple of things like streaming gRPC. I didn't realize that was a thing, so that was cool. Python circuit break. I wanted to give an example to someone. I didn't want to write it. Hash maps. So I'm trying to go back through some of the old algorithms and try to kind of refresh just to kind of get my brain back into it. I did a lot of different data structures in college, and that was a long time ago, and I don't remember most of them because I don't do low-level programming at all. And so, but that's what I want to do. I mean, this book, I don't know if you noticed, the Linux programming interface, amazing book, a little expensive, but amazing book on getting into the internals of the Linux kernel and really understanding how to use your Linux system. And since I'm trying to do more Rust with systems programming, I'm like, hey, let's get back into it. Networking systems programming, that's just kind of, I'm querying a few things about systems programming and networking, trying to learn, trying to get up to speed and understand. And then this is just a TCP server. I wanted to compare and contrast that with a book that I've been reading on network programming. Avoid unwrap. So yeah, I throw information at ChatGPT whenever something comes up. I feel like I use unwrap a little too much, and I wanted to try to get a handle on how to not use it so much. There's trained IH 464 and a 484, so I am a farmer and I like tractors, and I currently have 4 tractors and none of them work. One of them is the International Harvester 464, and there's a later model, the 484, that basically is the same one. They have the same engine. It's a 3-cylinder diesel, and I was like, hey, I found one on Facebook Marketplace that was super cheap, and I was thinking, hey, maybe I could buy it for a parts tractor to fix mine more. And I was just, hey, what are some of the differences to understand that if it's the proper thing? You might not see it, but right there is a calendar that I have that are a bunch of International Harvester Farm All tractors because they're fun. Skills improvement strat. I was like super duper tired, and I was being snarky towards ChatGPT, and I'm like, how can I get better at something without actually practicing? So that was that. And then these two are just a couple of more NeoVim things. I was getting an issue with tree sitter in Rust and doing some syntax highlighting, and I just didn't have the latest version of tree sitter installed. Once I installed that, I was good. And then if you're ever in NeoVim or in Vim and you search for something and like everything stays highlighted, I'm like, how do you clear that? Because it's super annoying. And so I was like, hey, what is the command to clear all of that so that I can map it to a key map? And that's it. I'm not going to go through the rest of them, but I am sure a bunch of you were nosy on that, and so I just wanted to run through what they were and why they are. Maybe give you some ideas for stuff. All super interesting and help me in the moment. So with that, I think of your time. This was a lot of fun, and I am ready to move on to the next episode next week, and it's going to be more into the networking side of things. I've played with a couple of things in Rust, so I think what I want to try to do next week is go over some concepts of what I want to build, how I'm thinking it'll work, a little more deep dive on the concepts of some of the networking stuff that I've learned, and maybe some approaches that I want to go through, and just kind of start, figuring out and like doing kind of a push-pull of what are the things that I want to do so that I can figure out how to approach doing this project. Again, I just want to be able to run this thing every so often, probably on a cron job in all reality, like every hour. I want it to scan the entire network and tell me what's there. And then if I want to look at it later, I can just call a command and it shows me everything. This will help for finding new things on the network and tracking existing things in a more interesting way. I'm sure there's software out there to do this, but I haven't really ever cared as much, and I'm like, hey, this is a good opportunity to start digging into dealing with systems programming concepts. I don't know that I'm going to go as low level as I could on this, at least not yet. So anyway, with that, I thank you for your time. I thank you for watching, and I will see you next week where we will start dealing with more network programming and systems level stuff. Thank you, and I'll see you later.